L5 is equal to omega such that omega contains ABA as a substring. Omega contains ABA as a substring. So you have an initial state Q0. You have an initial state Q0. Okay, you want ABA as a substring, right? So if you see a A, okay, the approach when you are constructing DFAs, the approach is to, from initial state you try to get to the final state, right? So you are looking to have ABA as a substring. So when you see A, you go to Q1. Similarly, you look to get B, so you go to Q2. And then if you see another A, now the string is qualified to be accepted. Whatever comes afterwards, it is qualified to be accepted. Now at Q0, now you have to fill for, because it is deterministic DFA. In deterministic DFA, you have to fill for every possible transition, right? So now when you are at Q0, if you see B, you stay at Q0, it does not affect. When you are at Q0, what does Q0 represents? In this DFA, 1 minute. Let's not define move for Q0 right now, for B right now, okay? So this is what you have made so far. From initial state, you look to get to the final state, and we have constructed DFA so far, and there remain some transitions. Okay, so what does Q0 represents? Q0 represents that for the substring ABA you have seen nothing. In the substring ABA, because you have to look whether in the strings ABA is a substring or not. So out of this ABA you have seen nothing like that, right? That is what Q0 represents. Similarly, what Q1 represents? Q1 represents set of all those strings. Okay, I can write. This is the first time. Listen, when you are constructing DFAs, with practice it becomes handy to you, and you don't, because I have to explain it, that's why I am doing it like this, but it takes 10 or 20 seconds or 30 seconds at max to construct a DFA. Okay, so what does Q0 represents here? Q0 represents that, so Q3 is set of all strings that has, 1 minute. So what does Q0 represents here? Q3 represents set of all strings that has ABA as a substring. Similarly, what Q2 represents? Q2 represents set of all strings that has AB as a substring. Q1 represents set of all strings that has A as a substring. You have to accept all the strings that has ABA as a substring, and Q3 is such a state. When you reach at Q3, now it represents, okay, all the strings that has ABA as a substring. Q1 represents set of all strings that has A as a substring. So Q0 has seen nothing of ABA as a substring, right? So if you see B, you stay at Q0. That does not change anything in the DFA. Okay. When you are at Q1, now Q1 represents all strings that has A as a substring. If you see a next symbol as B, then it should go to Q2, because Q2 represents all strings that has AB as a substring, so it is rightfully going to Q2 when it sees B. But if you are at Q1 and you see A, where you should go? Where you should go? If you are at Q1 means that you have seen A as a substring, the next symbol is A, then you should stay at Q1, because the resulting string is again the set of strings that has seen A as a substring. So on A you stay at Q1. Similarly, when you are at Q2 and you see B, okay, very good. Now when you are at Q2 and you see B, then where you should go? When you are at Q2 and you see B, where you should go? So when you are at Q2, it means that you have seen AB as a substring. AB as a substring. If the next symbol is A, then you have seen ABA as a substring. Now you should go to a final state, and that is Q3, right? So on A it is rightfully going to Q3. But if you are at Q2, it means you have seen AB as a substring, and the next symbol is B. It means what? It means to see ABA as a substring, you have to restart. You have to restart to see ABA as a substring, right or not? So from Q2 you go to Q0. If you see AB, you go to Q0. So this is the required machine for L5. So that's how you construct a DFA. You are at initial state, you try to get to a final state. Once you have made a skeleton of the DFA, now you look at what are the remaining transitions, because a DFA has transitions for each and every possible combination of state and a symbol. So you do it accordingly, and it is very easy. Let's take some more examples of DFA. So let's take summation.